Welcome back to video number 2, ladies and gentlemen. We're going to be talking more about solving a system of linear equations by graphing, find the ordered pair. This time we're going to apply some real-life application to that. And it starts off with your family starts a bed and breakfast, spends $500 fixing up a bedroom to rent, and the cost for food and utilities is $10 per night. Your family charges $60 per night to rent the bedroom. So example 7a says write an equation that represents the cost, and then write an equation that represents the revenue, that's the income, and then graph that. So if you recall in our very first video that you watched tonight, we made a table about the cost and the revenue, and we found where the break-even point was. And so we're basically going to be doing that now. We're going to find the break-even point here, where we are going to find the ordered pair that says, hey, this is how much it costs, this is how much we're getting in, and this night will give us the break-even point. And we'll talk about that when we graph it. Alrighty, so the first thing we're going to do is write an equation that represents the cost. I'm going to use red for that. So cost is equal to $10 per night plus the 500. So if we put that in normal terms, y equals 10x plus 500. That's how a lot of people like to write it, but you recognize that the cost in dollars, C and Y are represented by, represent the same thing. That is the cost in dollars to fix up the room and rent it in each night, plus the $500 that we use to fix up the room. And it costs us $10 a night to maintain the electricity and the food for the person who's renting it. And then we're going to come down here. I'm not going to graph it yet. I'm going to get my two equations before I have my graph. Write an equation that represents the revenue. That's the income, the amount of money that we're going to make when it's rented, and then we're going to graph that. So once again, the revenue is equal to $60 per night. So that's 60x, or y equals 60x, right? And so when we look at those, we can say to ourselves, the first equation, the slope is 10, the intercept is 500. And when we look at the second equation, the slope is 60 and the intercept is 0. That intercept is 0. And notice that makes sense. The intercept is 0 because we're not going to make any money until we rent the room. So that's a proportional relationship. The first equation, we have the intercept is 500. That's not a proportional relationship because it cost us $500 before we ever rent the room one night. Then when we rent the room the first night, it's going to cost us another 10 bucks. Alrighty, so let's come over to our graph using the information from our equations. We know that we have an intercept of 500. So somewhere on this cost side, the money side, we know it's the y is the cost because it says so in dollars and in revenue is in dollars. So we got to get at the 500. So I'm actually going to go by 50. So we have 0 here at the origin up to 100, 150, 200, 250, 300, 400, 500, 600, 700, and so on. And then we have the nights that we're renting it. That's going to be the x-axis, the nights. And I'm going to erase that because you know what? If I'm going to ask you guys to do your work with excellence, I got to be able to do a little bit of excellent work here. So the nights is the x-axis, and I'm just going to go by ones, and I'm going to hope, and I'm going to pray that by we get to the end, we're going to find a solution, an intersection, a break-even point on the number of nights. That's 11, and then 12. So 12 nights. Once again, I'm going to erase that real fast and make a nice 11 there because I want it to look nice. Okay? So we're going to go to our first equation. That's the red one, and we're going to say that our intercept is 500, the cost of fixing up the room before we even rent it. And then we recognize that the y-axis goes up by 50s. Well, the slope of 10, that's going to be hard to do every single time. We recognize that if I go into 50, 10 goes into 55 times. So if I use 5 nights, I can say that 10 times 5 plus the 500, well, that's going to equal $550. So I'm going to go over here to 5 nights up to 550 and put my next point. And then I realize that if I go 10 nights, that's 10 times 10 plus the 500. So after 10 nights, it's cost us $600 for that room. After 10 nights, it's $600 for that room. Using your straight edge, voila, you can draw a nice graph. Okay, let's go to our revenue. And again, the intercept is 0 because we realize we're not going to make any money if we haven't ever rented the room. And because we used 5 nights and 10 nights for the cost, let's use 5 nights and 10 nights. 60 times 5, well, that's 300. So at 5 nights, we can go up to 300 and put our first, another point. And then 10 nights, whoa, I just saw something. 10 nights is 600. Voila, viola, right there. We did get it. Just barely, but we did make it. So our ordered pair solution, 10, 600, that represents 10 nights, $600 break-even point. Okay, so 10, 600 is the ordered pair solution, and that represents 10 nights at $600. Anytime over 10 nights. So when we rent our 11th night, we're going to put money in our pocket. We're not paying off the cost of fixing that room anymore. We're not paying off the cost of well, we are, the $10 per night. So if we rent it for $60 and it costs us $10 for food and electricity, we're putting $50 into our pocket. So let's go to our next example. There are 26 students in your room, 26 students in your class, excuse me. There are 4 more girls and boys. Use a system of linear equations to find out how many boys in your class, how many girls are in your class. So, ladies and gentlemen, let's see here. We've got to write 2 linear equations. We've got to write our system of equations, but now they don't give us any help. So we have to recognize. And I'm just going to sit here and I'm going to go, well, I know that there's 26 students in the class. So I know one equation has to equal 26. I know that. And I know that there's only boys and girls, so I can say the number of boys plus the number of girls. Well, that's 26 students. And you're not used to using different letters than X and Y. So if you want to think about it, that B, the number of boys, we're going to say is X, and G, the number of girls, that's Y. So I could come over here and say X plus Y equals 26 if I wanted to. All right? All right. Now we need a second one. We got to have a system. It says use this, let's see. Here's the other important information. There are 4 more girls than boys. So we know that the number of girls has to equal the number of boys plus 4, because it says there's 4 more girls than boys. So the number of boys plus 4 is equal to the number of girls. Some of you might have thought it would be girls plus 4. Well, no, that would be too many. That would be 8 more than the boys. So the other way, if you wanted to subtract, you could say the number of boys is equal to the number of girls minus 4. You could. So either one of those might work. And of course, this would be y equals x plus 4. And down here, this would be x equals y minus 4. Well, we want that one that looks like slope-intercept form, and we're going to graph those two. So going here, I'm going to graph the first one right here using red, putting that in slope-intercept form. Y equals negative x plus 26. Oh, wait a minute, I need my graph, huh? I almost got too carried away. So on my graph, let's use purple again. I'm going to take, and my y is going to be girls. Sorry if it's hard to see, that's why I'm using purple. And my x is going to be boys. And I'm going to go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And the number of boys, I'll go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We know that the number of girls is more than boys, so we're not going to have 22 boys. All right, so let's go back to my red. We're graphing the y equals negative x plus 26. So I start out at that 26 as my intercept. I'm going down 1 over 1, down 1 over 1. So I know that it's going by 2s. So I know that every one of these is going by down 2 over 2, down 2 over 2, which is the same as down 1 over 1. So I know that somewhere on there is going to be my number of girls and my number of boys. So let's start with the blue and go to this y equals x plus 4, where my slope is 1 and my intercept is 4. I didn't do that on the last one, I apologize. So 2, 4 right here. When I'm doing this graph, I'm starting at 4. And this time I'm going up 2, over 2, up 2, over 2, and voila. And we go through there like that. And we see that this intercept happens right in there in the middle. So if we take, I'm going to take, I'm going to take yellow. Hopefully you guys can see it. And I know it goes this way, and it goes this way. Well, if it's right in the middle, that's right here. That's going to be what? How many is that going to be? That's right. That's 15. And if it goes down, it's going to be 11. So I know that X is 11. I know that Y is 15. I know that X and Y represents the number of boys and girls. And if I add those two together, 15 and 11, that equals 26. So the number of boys is 11. The number of girls is 15, as I got it from my solution by graphing. Ladies and gentlemen, you have a quick write. Once again, I did give you this graph for you to put into your note. We already glued it in, so all you have to do is pause this so you can look, and then you can write the system of linear equations that represents the situation. Figure out how to make your graph. This is going to be a good one for us to talk about in class tomorrow, and then find out how many of each you have. Thank you so much for your time. If you have any time left over, please feel free to work on as much of your assignment as you can get done so we can spend more time talking together in class and confirming what you know. Bye.